Hey everyone, welcome back to Engineered Baking. Thank you for watching my last video. This week we're going to take a look at a slightly different cookie recipe than last week. This one uses mass to measure out ingredients rather than volume, so I'll show you how to measure out one of my favorite ingredients to use in cookies, brown sugar, and we'll also take a look at some heat transfer modes that occur in the baking process. When using mass to measure ingredients, you will need a measuring scale. These are not too expensive and are a staple of many kitchens. It is helpful to have a tray or something to put your ingredients on when measuring, in this instance using a Tupperware container. If you turn the scale on with something on it, it will automatically zero itself, saving you from having to do math on the ingredients. Here, we are trying to get to 200 grams of brown sugar. Scales do have certain margins of error, so we'll try to get as close as we can with this. Once we finish measuring out our ingredients, we will start putting them into the mixing bowl, adding the butter first, then our sugars, including our just measured out brown sugar, and a mixture of baking soda and kosher salt. I like to leave the butter out for about half an hour to an hour prior to mixing, and this will help soften it and bring it up to room temperature. Generally, I find it easier to mix in if the butter is a little softer and not fresh out of the refrigerator. Once these ingredients are fully mixed together, we will keep the mixer going on low to medium low, and we will add in our eggs and our vanilla extract. Adding these while the mixer is going will help to incorporate the liquids into the dough better. We want to have the mixer going as we gradually add in flour to the mixture, using a spatula to scrape any flour that gets stuck to the side of the bowl back down into the dough. The speed will still be low to medium low, and as before, you will want the flour to be fully incorporated into the dough prior to adding in more ingredients. One more practical reason to keep the mixer on low to medium low is that it makes it easier to practice your ninja skills and deftly dodge the moving mixing blade. Getting your spatula caught in the mixing blade can not only pose an injury risk, it can also damage your mixer or spatula, so be careful while mixing your flour back into the dough. Once the flour is fully mixed in, we will stop the mixing blade and scrape off the remaining dough back into the bowl. After this, we can mix in the chocolate of our choice. The recipe calls for chopped chocolate, however, if you are feeling lazy, chocolate chips are a fine substitute, like I use here. One advantage to using chopped chocolate is that you can control the size of the chocolate and make it finer, allowing for a more complete mixture. Before we put anything into the oven, I would like to take a brief minute just to talk about heat transfer. Heat transfer is fundamentally the transfer of thermal energy. So in this instance, we are transferring energy into the raw cookie dough, transforming it into a beautiful, delicious cookie. There are three modes of heat transfer. They are conduction, convection, and radiation. With conduction, that involves materials being in direct contact with one another. So in this context, think of it as the raw dough sitting on the baking sheet. The baking sheet is heating the dough from underneath it. Convection involves motion through a medium such as a liquid or a gas. In this case, it involves the transfer of energy through the hot air that exists within the oven itself. Now, there are convection ovens that exist, and they will utilize fans to force air to travel throughout the oven, and that is a more efficient form of convection than just the regular convection that will exist from the temperature gradients that exist within the oven itself. However, most ovens that exist in people's houses and apartments are not convection ovens, and they only heat up by using a coil on top or bottom of the oven. And that brings me to my third mode of heat transfer, which is radiation. Radiation involves the use of electromagnetic waves heating up an element. So in this case, what is going on is the coil in the oven is glowing so hot that it'll help transfer energy into the cookie dough. In the oven, on the left, we have an upside down glass baking dish, and on the right, we have an upside down metal baking dish. The reason for this is that glass cookie sheets are incredibly hard to find, and we wanted to try and keep things as similar as possible between the two. One important thing to remember as you experiment with different cooking techniques, ingredients, and dishware is to try and have a control as a baseline to compare and contrast your results. Normally, we would use a metal baking sheet, so we are using an upside down metal baking dish to approximate that. Next, we will use something closer to an actual cookie sheet for how the cookies are supposed to be, and because who doesn't love a good time-lapse of cookie dough turning into the finished product in an oven? So most of the cookies kind of look the same. These are the two ones that were done with the pan metal, and these are the ones that are done with the glass. So if we take a look on the underside of them, we can kind of see where the difference exists there. As you can see, the ones from the metal are definitely darker and a little more burned. The ones from the cookie sheet are also darker. And the reason, again, for that is that the metal heats up faster and therefore cooks the cookie longer. Hey everyone, thank you for watching my video. Really appreciate it. Join me in a couple weeks. The next video I post will be talking about the ingredients you use to make your cookie and how they can affect the final outcome of your cookie, depending on how you want to make it, whether you want to make it chewy or crunchy.